Okay, so this is our lens. This lens is called a converging lens. Converging lens means the light ray will bend towards the principal axis. Okay, what is what? Okay, this is your principal axis. Principal axis. Okay, this is a principal axis. So, axis is a line that cuts through the center of the lens. The center of the lens is known as the optical center. Okay, so all these are imaginary line. Of course, the principal axis is an imaginary line. Okay, optical center is the center of the lens. Alright, and then this thing called principal focus. What is this? This is otherwise known as a focal point. So every lens will have a certain focal point.
Optical
center. Okay, center of the lens. Okay, then every lens will have a certain focal point. Okay, so you wear specs, there will be a certain focal length, there will be a certain focal point, right? Okay, so the focal point can be somewhere here, and we use the letter F. Okay, and when we measure this distance from the optical center, you remember from last year, the teacher taught you this distance is known as the focal length. Yes, so this is the focal length. So different lens will have different focal length, right? Okay, so let's write down the definition of focal length here. I'm going super fast, so you got to be really fast. So focal length means the distance. Okay, use your common sense and tell me how to define this. Focal length is the distance between
the converging lens and
okay,
focal point
the focal point and the optical center. Okay, be more specific, between the optical center and the focal point. Okay, so that is your focal length. Okay, the distance between these two, right? So it's quite a commonsensical definition, if you understand what you're doing. Okay, so how do we draw ray diagrams? Okay, a converging lens, normally I'll just draw a converging lens like this, with two arrowheads like this. Okay, so the general idea is this. You see, if light rays, you got light rays that comes at all angles, hit the lens in all directions and so on. You cannot predict the path. You don't know where everyone is going. However, there are two light ray paths which you definitely can predict. Okay, and which are the two? One, the very first path which you can predict is that anything which is parallel to the principal axis, anything parallel like this, they will go and converge towards the focal point. So you can predict this. So anything that's parallel like that, I know, it will go towards a focal point. Okay, that is one predicted path. You know one for sure. The second predicted path is, who knows? Anything that goes towards the center of the lens, what happened?
bends away.
No, it doesn't bend away. It goes straight through. Okay? In this case, you go straight through. So anything that is towards the optical center, you just have to draw it going straight through. Like that. Okay? So these are two predicted paths. There are millions of light rays. They all come at all different angles. So you don't know which one to, how to draw. Okay, but you know these two, how they go. Then how they bend or not bend. And then you can draw already. Okay? Your light ray diagram, okay, which I'll show you soon. Okay, so this one is one predicted path, So when they hit here, these two light rays meet at this point. We call this point the focal point. Okay? So if I have another one that's coming here like that, it will simply go straight through. Okay, I'm not using ruler. So you got to use a ruler. You don't draw like that freehand. Sure mark you wrong. Okay? Okay, so this is called the focal point. Okay, then you will see on a light ray diagram something called 2F. What is 2F? Don't say second focal point. It's not a second focal point. It's just a position. It is a position which is known as, which is double the focal length away from the optical center. Okay, so if I tell you the focal length is 5 cm, that means 2F is 10 cm away, okay? So it's not second focal point, you must remember that, alright? Okay, so let's fill up these blanks here. Focal point means the position on principal axis where all light rays parallel to the principal axis converge after passing through the lens. Okay, so those are your definitions. Okay, your definition is not going to be as important as how you know how to draw your light ray diagrams. Okay, and then to describe the image as well. So when you are asked to describe the image, you either say they're diminished or magnified, upright or inverted, real or virtual. Okay, so these are the adjectives you use. Okay, so you see the very first instance is this. The object starts at infinity. That means very far away. Okay, so very far away, this one I already draw for you. Anything far away, the light ray will come parallel like that. Okay, this one will just go straight through. Then this one will run parallel. Then you say, how you get this? How I get this is the same as this. It's only that the light ray, okay, it is the same as in this case. Only you know this one, it will go towards the focal point. Right? This one will go towards the focal point, right? You all know that, right? So if I draw it the other way round, okay, if the light ray goes through the focal point, how will this go? It will run parallel. Okay? So it's just a reverse path. That means you will take back the same path that it went by. Okay? So that's why over here, your light ray path goes like that. Okay? Parallel. So where will this image form? It will form at the focal point. So anything very far away, the image will form at the focal point. Then how we describe it? We describe it as inverted. Real. Real means what? Can you remember first lesson? Real means the image can be... what? Real means... Jinglan real means can be seen. Everybody can be seen. Can be captured on a screen. Remember, can be captured on a screen. Alright? So, what does it mean? Javier, it means that if I put one screen here like that, I will see it on the screen here. Okay? At the focal point. That is what it means, can be captured on the screen. Right? And then the image is diminished, smaller. Okay? Is inverted, upside down. Alright? Okay. And where do you have such a thing? Telescope. So when you use telescope, you look at the moon. Okay, the moon appears smaller, definitely smaller, right? Okay, it doesn't appear larger, right? Okay, and so it's a good example of a telescope. Okay, now so a typical ray diagram looks like this. You see our lens is here, then you got F, focal point, 2F, 2F. Okay, so this is the next case, your object is here. So when I draw the object, it's normally an arrowhead. Think of it this way. This is the guy's feet, this is the guy's head. Alright? So it's a whole thing. Don't say, hey, the object is this point here. No. Head, feet. This whole thing is the object. Okay. So how do you draw this? There are many light rays coming out from this object. They are giving out light in all directions. So you cannot predict a lot of them, except two. So Jinglan, the first light ray you should draw is what is it? Straight. You take a ruler, you put and draw parallel, right? Okay, so you draw. Okay, here all freehand. So mine is going to look very inaccurate. So I take a ruler, I draw like that. Okay, hit the lens already. Javier, where does it go? Down where? F or 2F? Always towards the focal point. Okay? Always towards the focal point. Anything parallel will go towards the focal point. So like that. Towards the focal point. Okay? So it goes towards the focal point. Right down like that. Okay? Okay, so you need at least two light rays to find the image. So the second predicted path, which you also know, is that anything that I'm going to draw, take a ruler, go towards the optical center. I think it's called optical center. So you look like that. You will go straight through, correct. This one will go straight through like that. You go straight through like this, like that, correct. Okay? Okay, now, then you ask yourself, hey, where's my image? My image is here. Right? Now you started from the guy's head, so you will form the image of the guy's head and then the feet will appear here. Okay? So from the head, you form at the head. You got it? Now you look at each other's diagram, you see, hey, mine is slightly different, he's slightly nearer, he's slightly further apart. Okay, depends how accurate you draw it. And after you draw all this, don't forget one thing very important, everybody must draw arrows. Okay? Then when you're asked to do the characteristic, you say, I never memorize. Don't need to memorize, just look, you will know. Look and observe. How you know inverted? Okay, some people, they don't know, they are memorizing. Inverted, why? Because you see, this guy's head is here, feet is here. In this case, his feet is now here and the head is there. It is obviously inverted. Okay? So you don't need to memorize. So it's inverted. Okay. And how you know it's diminished? Again, you compare now. You see this one so tall, then this one becomes so short. So it is called diminished. Alright? And it is real. How come real? Real because you actually have light rays from here and here forming your image here. Okay? They actually form the image. So if I want to capture on a screen, I must put my screen here. I can see the image already. Okay? So where is such an application example is your camera, your eye. Our eye is like that. So we see things like this. Alright? Then you see, how come I don't see you upside down? Okay, I don't see you upside down. It's because God, everything well in advance. He created such that the wires that go from our eye go to the brain, it will flip the image upright. If not, we see you upside down. The whole world will be upside down. Right? Then that we headache, man. Right? So at the back of the eye is like a screen, and you could see the image that's captured in the back of the eye. All of you will appear upside down to me. But then from the eye, connected to the brain will flip it the right way up. Okay? Amazing, right? Okay. So that's first case. Now second case at 2F. So you see our object getting nearer. Come to 2F. Now 2F is a significant case. Right, remember this, memorize it. At 2F, you're going to get the same size. The image will be at the same size. So it's worth remembering this. Image will be same size. And form at... And form where? Can you all remember? If you had the object at 2F, the image will also form at? Good. Remember this. Is an advantage. Okay, so sometimes they ask you, they don't ask you to draw. MCQ never ask you to draw. They say, the image is at 2F. Okay, describe the characteristic. Then you say, how I know? I must draw, is it? No, you don't need. You just remember it's the same size. Same size, also inverted, also real. Okay? Okay, now you all try to draw. So here, you try to draw accurately. You can play cheat in a way. I can play cheat by drawing my image first. I draw the same size. If you don't play cheat, in that sense, you draw, you might see, hey, mine is slightly off 2F. Okay, I can't get it at 2F. It's because we can't draw that accurate. So you draw, it should look like this if you draw it accurately. And here am I drawing without a ruler. Okay? And then after you draw, I forgot to tell you, always label your image as image. Okay? Okay, so there's a 2F. So 2F, remember, it is same size. So application, a photocopying machine. So photocopying machine, I photostat a piece of paper. Okay, I want the same exact replica. I don't want bigger, don't want smaller. That means my lens must be 2F away. So if I say my focal length for my lens is 10 cm. Hayden, how far must I put my paper in order to photostat the same size? If it's 10 cm focal length, then I must place my paper at 20. Okay, so that's a significance you must remember. Okay, so you don't say half blur. I don't know. Okay, can do it one. Okay, next one. Okay, your next one. Draw yourself. Okay, practice the drawing. It is behind the lens. It's not just behind the lens. Now you know. I show you how you know it's virtual. You are right to say it's behind the lens. By the way, label. I'm going so fast, I forgot to tell you label. Image is here. Object is here. Alright? It is behind the lens. But you notice when I draw backwards, I use dotted lines. That means the image appears to come from the back of the lens. Behind the object. So the image appears at the back. So what I get is a virtual image. I don't get real light rays. These two light rays here form this image. These two light rays go backwards, appear as if they're coming from backwards. You get a virtual image. Okay, so that's what a virtual image is. So if I were to put a screen here, can I capture?
No.
Cannot. Right? Cannot. Why? Because it appears as it's coming from the back, but actually it's not there, right? Okay? So this is the most common example you all must remember. Okay? And the application is magnifying glass. Right? You use a magnifying glass, you notice every time you use a magnifying glass, you look at the end, all this, the end or the object never appears upside down. It's always upright and always bigger. Right? And then when you take a magnifying glass, can you just put very far away from you? No, right? You notice you always have to go quite close, right? Why? Because this situation only occurs when what? The object is within the focal length. Okay? So this only happens when the object is within the focal length. That's why when you use a magnifying glass, you cannot use it too far away. You have to look at it close by. Right? So if I say so you got to read the MCQ again. If they say the focal length of this lens is 10 cm, then they say I place my object at 8 cm. Straight you must think, okay, it's going to be virtual, it's going to be upright, it's going to be magnified. Got it? So the two so-called important cases are like that. One within the focal length, and the other one at 2f. So JB at 2f, what's so special? The image will be at 2f. At. You forget so fast. At 2f. This called smaller, man. Same size. Object at 2f. When it's at 2f, it's the same size. Okay? Then within 2f and f is bigger. Okay? And then within optical center, within the focal length is also bigger, but virtual and upright. Okay? Wasted you don't learn this. So much better to do this than next. Right? Okay? So that's the drawing bit.